Hi everyone, in this video we going to see about the RSA algorithm, so which is our reversed Shamir-Edelman algorithm. So this is the block diagram which denotes the RSA algorithm. So this is one of the first widely used public key crypto system, and it remains one of the most important cryptographic algorithm today. It is primarily used to secure data transmission, and it works based on the computational difficulty of factoring large composite numbers. So RSA provides both encryption and digital signature. So and this is a process of RSA algorithm. So look at this diagram. Here a plain text, we are using an encryption algorithm. That is, when we say want to send a message between A and B, first the encryption is done by the public key of B. We are generating a cipher text, and the decryption is done by the private key of B. We are not using the keys of A. While we are doing the reverse process, reverse process, we can again use private key of B. So another way is we can use the private key and public key of A. That is, either we can use the public key or private key of A for encryption and decryption, or we can use the public and private key of B for both encryption and decryption. So this is what our RSA algorithm. So here RSA is an asymmetric encryption algorithm. It uses two different keys, which is public key and private key. Always public key is used for encryption and private key is used for decryption. So the main key concept of this RSA algorithm is public key, which is used by anyone to encrypt the message for the key owner, or they verify the digital signature. Private key, they are used by the owner to decrypt the messages or to create a digital signatures. Prime numbers, the security of the RSA highly relies on difficulty of factoring the product of two large prime numbers. It is what prime number we are choosing to do with the RSA plays a major role in the difficulty of RSA algorithm. Next, what are all the steps involved in this RSA algorithm are: first one is the key generation, the next one is the encryption, and another one is the decryption. So in the key generation process, in order to generate the RSA key pair, that is public and private keys, the following steps has to be followed. That is, for generating keys for public key and private key, we have to choose two large prime numbers. Here we are taking the prime numbers as P and Q. Next, we have to compute their products, where n is equal to P into Q, where the modulus n is used as a part of both public and private keys. Next, we have to calculate the Euler's torsion function, which is phi of n. So our phi of n is equal to P minus 1 into Q minus 1, and we have to choose any integer such that the E should be between 1 and phi of n, and the E should be a co-prime of phi of n. So co-prime means the GCD of E and phi of n should be 1. Next, we have to compute the private key called D. That is, D into E should be congruent to 1 mod phi of n. So where that D is the private key. So after calculating the public key, private key, phi of n, E is the public key, D is the private key, we can pair them as public key as En and the private key pair as Dn. So after finding out the public key and private key, we can go for the encryption and decryption process. We can go for encryption and decryption process. So here the encryption means we are converting the plain text to cipher text. For that we can use a formula, which is C is equal to M power E mod N. The sender transmits C to the required recipients. Next, we can do the RSA decryption. To decrypt the cipher text, the recipient uses their private key pair, which is D comma N. They can perform the following steps. So they can compute the original message by using the formula. your m is equal to c power d mod n. So here I have given the formula, right? So m is equal to c power d mod n and your c is equal to m power e mod n. So these are the two formulas which is used for encryption and decryption. So that is what we are just we are just computing a public key E, private key called D, and after computing public and private key pairs, we are just doing our encryption and decryption process. So here there is RSA. It remains a critical and widely adapted algorithm in cryptography, and it enables secure communication, encryption and digital signature by leveraging the mathematical difficulty of factoring of larger prime numbers. So that only RSA has its own uniqueness, and that this algorithm is currently widely used in the industries for secure data communication. I hope you understand the RSA in a clear way, right? So thank you.